All right. So volcanoes.
Oh, why is that one white?
So volcanoes are an opening in the Earth's crust that erupts gases, ash, and lava. And Kilauea in Hawaii is the world's most active volcano. There are three main effects from volcanic eruptions. One of them is lava. And lava, although highly destructive, you can often outwalk a lava flow. So it's pretty slow. It's slow moving. Although the temperature is extremely high and it does destroy everything, if it's just a flow of lava, you can outpace it or you can avoid it. Nikita?
Is there anything that lava can't destroy?
Not really, because the temperature is the same as the inner part of the core or the mantle. So the temperature is thousands of degrees. So typically it will destroy everything in its path. Kat?
So you can walk a lava flow, but when it erupts and it goes faster, you can't outwalk that.
No, that's a little bit different. That's called a pyroclastic flow, which we'll talk about in a second. So a pyroclastic flow, you cannot outwalk. You cannot outrun it. You cannot it's pretty hard to outfly a pyroclastic flow. So a second effect is volcanic ash. We often think of volcanic ash as being very fine, which it is, but it's rock. So when it accumulates on the roof of houses during a volcanic eruption, it's often heavier than snow. So think about when we have snow on our roof, we have to clean that off. Volcanic ash can often collapse roofs. So people will often take shelter inside during a volcanic eruption, and if it's bad enough and there's enough volcanic ash, it ends up collapsing buildings. The other part is because it's rock and it's very coarse, but it's very fine, as you inhale or organisms inhale, they inhale volcanic ash as well as oxygen. And that volcanic ash mixes with the moisture in your lungs that's naturally there and turns into liquid concrete. So you literally suffocate to death from volcanic ash. Flying, because it also impacts airline flights, because it gets into like plane engines and car engines and stalls them out. So planes have to avoid volcanic ash in order to keep from crashing. So they often track volcanic eruptions to keep the airline flights even above or below the ash cloud. You will see both of these in the video we watch on Friday, which is the super volcano video, talk about a lava flow, volcanic ash. A pyroclastic flow is the worst part. A pyroclastic flow is volcanic ash, debris, but it also has the heat of the lava. So temperatures inside of a pyroclastic flow are high enough to actually instantaneously evaporate water. So if you're caught in a pyroclastic flow, you literally instantaneously turn to carbon, solid carbon. The first inhale of a pyroclastic flow would be your last because it would incinerate your entire respiratory system. And you would be virtually just vaporized. So there's many volcanic hazards. You have the lava, you have the eruption column. The eruption cloud can also impact places farther away. So the eruption cloud will be taken by the prevailing winds and rain down. That ash will rain down on other cities much further away than the volcanic eruption. So how do the volcanoes form? They form deep inside the earth, and then the heat and pressure causes rocks to melt, forming magma. The magma is less dense than surrounding rock, so it's forced upward towards the Earth's surface. As the lava flows out, it becomes a rock around the vent. The steep depression around the vent is called a crater. Magma that reaches the surface of the Earth and flows outward through an opening called a vent. So there are pretty much three types of volcanoes. First one is on convergent boundaries. So we get them on convergent boundaries, we get them on divergent boundaries, and we get them on hotspots. So convergent plate boundaries include areas of subduction, and they tend to erupt more violently than other volcanoes. So we often talk about the Pacific Ocean as the Ring of Fire. Yes, it's a song. an old country song, but it's also referred to as the Ring of Fire because it is a ring of volcanoes around the subduction zone of the American and Eurasian plate to the Pacific plate. And it can also form island arcs or a series of volcanoes at convergent boundaries. Jake,
What are all those red dots on there?
those are all the volcanoes of the Pacific Rim, all those red dots. So that's why it's called a ring of fire, because it's there's so many volcanoes in that particular part of the world. Another place we can get volcanoes is on divergent plate boundaries. So Iceland being one of the most notorious or the best known, sits on top of the mid-ocean ridge. So as lava flows from the seafloor spreading, it builds new seafloor. Sometimes that seafloor rises above sea level and forms a new island. These tend to be a little less violent because of the type of rock that's melting there and forming into volcanoes. The last type are well known are the Hawaiian Islands. Hawaii is right in the middle of the Pacific plate, so it's not on a plate boundary. It's on what we call a hotspot. And there's not really a whole lot known as to why there's hotspots, but a hotspot are just areas of the planet that the mantle is unusually hot. And the rock melts at these spots and is forced upwards as magma. And it forms island chains. Now remember, the Pacific plate is moving. It's moving in a northerly direction. The hot spot is not. It's staying in its location. So as the plate moves north, it forms new islands. So it melts rock, forms a new island. That plate slowly drifts off the hot spot, but the hot spot's still melting rock. So the big island of Hawaii will eventually move off the hot spot and slowly start to get smaller as the volcano goes extinct that's on there since it's off the hot spot, and weathering and erosion start to become a bigger impact on it and start to make the island smaller until eventually it will be back under sea level, and it's known as a seamount. And if we look underwater from Hawaii, we can actually follow ancient Hawaiian island chain all the way up to Alaska. So islands that are now underwater, seamounts that used to be the old Hawaiian islands. So here, they're all in a line. So the Pacific plate is moving over the stationary hotspot. Kilauea, which was once located where the big island is, where big island of Hawaii is now located, that island moved and became dormant. So if you've ever been to, anyone been to Hawaii? You'll notice that the islands get smaller the further north you go, and that's because those are off of the hotspot. They're going dormant or extinct, and now weathering and erosion is taking over and weathering them down. So what controls eruptions? There's a couple of factors that control how violent an eruption is going to be. One is trapped gases. Gases such as carbon dioxide are trapped by the magma by high pressure. As the magma rises, the pressure decreases and it starts to form into bubbles. Very similar to a shaken water bottle or shaken soda bottle. If you shake the soda bottle, you can feel the pressure a little bit on the plastic, but as soon as you release the cover, it turns into bubbles and starts to erupt out of the soda bottle. So magma gas can easily escape gives you quiet eruptions. When they can't escape, you get violent eruptions. Another factor is water vapor. Water vapor increases at subduction zones, so the buildup of water vapor can cause a much more explosive eruption. Nikita?
Is it so quiet that no one can notice it? Or?
No, I'm talking like it's kind of like you'll notice a volcanic eruption, but it's just kind of bubbling out. So a quiet eruption would just kind of be like oozing out of the volcano, similar like Hawaii does. The lava just kind of flows out. Versus something like Mount St. Helens, where it's like a bomb explodes and the whole side of the volcano just erupts, and you get what we call a gray eruption. So that would be an explosive eruption, a very violent eruption. So the composition of magma also controls eruptions. If you have a magma that is poor in the mineral silica, known as basaltic magma, it tends to escape gases easier. There tends to be less water vapor, so you get a quiet eruption. It's known as a red eruption. You just get lava kind of oozing out of the volcano. If it has a high amount of silica, your granitic magma, your granitic rock, it's very thick and stiff, and the gases can't escape. So it ends up building up pressure and building up pressure until it just explodes. And this tends to happen where plates are converging or subducting. Typically, more often subducting, because that's where you get a lot of explosive, violent eruptions. Jake.
My sister lives in Hawaii and she's on the Big Island right now,
Mm-hmm.
next to the volcano. She's like camping out or something there.
Nice. So she's hopefully she can stay away from the volcanic eruptions that are happening by the volcano. They typically close areas of the island if there's an eruption going on. All right. So some magmas have an andesitic composition. Andesitic magma, again, is between the two. It's more silica-rich than basalt and less silica-rich than granite. So often form at plate boundaries where one plate slides under, so again, subducting zones. Many of the volcanoes encircling the Pacific Ocean are made of andesite. You get a mixture, because those are, one's a basaltic plate, one's a granitic plate, so depending on how much melting is going on at that subduction zone, will tell you how much, or potentially will give you how much basalt's right now mixed in that lava versus granite. So we have three types or three shapes of forms of volcanoes. A shield volcano is indicative or tells you that it's typically a quiet eruption of basaltic lava. And it just spreads in flat layers. So it's a broad volcano with sloping sides. This is very common like in Hawaii. It's a very flat island. You'll have like a little lava flow will happen over here, but the rest of the island you can do whatever you're typically doing, vacationing. And they'll just close off a particular part of near the lava flow, and everyone will go about their business. It's not really a big deal for a lava flow. When you talk about cinder cone volcanoes, those are explosive. They tend to throw lava and rock high into the air. These typically contain a lot of gas in their lava, but they're low in silica. So bits of rock and solidified lava are dropped from the air called tephra. The tephra falls to the ground and forms a steep-sided, loosely packed volcano. It often looks like a giant anthill, is how I think of it. It looks, and all you're going to get here is gray eruptions and rock. And then the third type is a composite volcano. These vary. This is your most common type of volcano. Sometimes you'll get a quiet eruption, sometimes you get a violent eruption. It's not every other. It's like there could be 2 or 3 quiet eruptions, then a violent eruption, then another violent eruption, then a quiet eruption. But they alternate in layers of lava and tephra. These are the highest in silica, and they often contain dikes or sills, which are structures that help strengthen the volcanic hill or mountain. And that has to do with the way lava cools between them, between the layers. So there's a few igneous rock features that we're going to talk about. First one is I'm going to go back and forth between this definition and the image that I just passed. So it's the largest igneous feature that forms when magma is forced upward toward the Earth's crust, cools, and solidifies underground. You would say most of New Hampshire is a batholith. The magma cooled underground, the volcanoes that were here and the mountains that were here weathered and eroded away, and you're standing on magma that cooled underground millions of years ago. So that would be down under here. So the magma that ends up cooling underground. Then you have what is known as a dike, and it's when magma is squeezed into a vertical crack and cuts across rock layers. So it goes, too far, up this way.
Thomas, no fleet for dismissal, please.
Okay?
Tom, no fleet for dismissal.
And then finally, the last one is a sill, and when magma is squeezed into a horizontal crack between the rock layers. Right? And that is just like a windowsill. Right? And it kind of is on the horizontal.